Alright, AP Physics 1. Today is the first day of actual physics content here in class because we are starting Unit 1, Kinematics, a Graphical Analysis. Now this entire unit is really going to be focused on graphs and what graphs can tell us about certain physical scenarios. However, the overarching theme is kinematics, which is actually the theme of this unit and the next unit. So the first question you probably have is, okay, that's all well and good, but what does kinematics mean? So let's look at this very first part here, kinema. Kinema is a Greek word, and if you look at it, it might look a little familiar, because kinema sounds a lot like cinema. And what is a cinema is something that has to do with movies or motion pictures, because kinema is an old Greek word for motion. And specifically, kinematics is the scientific or mathematical description of motion. Kinematics is how we describe moving objects in very physics terminology to other people so that we can make sure we're all on the same page. We're not looking at why things move. Right now we're only looking at how they move, specifically the details of how they move so that we can relate that to others. We want to get this down before we can start focusing on the why. But what is motion? Now you probably have a good idea, but this is something I want you to look at. It actually comes back to cinema. This is an old photograph, and so was the photograph at the very beginning of this video of the horse, by a gentleman by the name of Edward Muybridge. I'm honestly not 100% sure how to pronounce his name, from the 1800s, who did a lot of studies of motion using photography. Essentially, he would set up a camera, and it would get tripped at various times so that he could take multiple pictures in a row of people moving. Well, if you look at this picture, how can you tell that this couple are moving, and specifically that they're dancing? From looking from one picture to the next. How does this give the illusion of movement, even though, really, if you look at one at a time, there's no movement actually occurring? And that's because there is a change in position. Now, specifically here, the position is basically the changes they're moving around in a circle. They're rotating. But position actually has a very specific meaning in physics. But right before we get to that, let's go ahead and formally define motion. It is simply a change in position. An object has moved when it changes position, and an object is in motion if its position is currently changing. So what does position specifically mean in physics speak? Well, position is where an object is located relative to a coordinate system or a reference frame. Let's kind of work through what exactly that means. Typically speaking, if you want to identify where something is located, and you're telling someone else, you relate it to something else. So for instance, currently I am in front of my computer. You are probably next to your desk or your bed. We could say that, for instance, here, let's actually bring up an example real fast, that this orange cube and this aquamarine cylinder are next to each other, and specifically we could say the aquamarine cylinder is to the right of the orange cube, or the orange cube is to the left of the aquamarine cylinder. But a lot of these things are arbitrary. What does next to mean, or by, or right and left? We want something that is truly universal. So to do that, we need to establish a couple different things to formally define the position of an object. First off, we need to define an origin. Now keep in mind when we say origin, what we really mean, let's use red, is some sort of 0 point. We need to say that that is what we are referring to. We are picking a point that we're going to define everything around. So I'm going to go ahead and say that this location right here, I'm going to call my origin. It is totally arbitrary. I could have picked here, I could have picked there. It does not matter as long as you define it. Additionally, though, now that I've defined that, well, I need to be able to say, is it this way or that way? So I need to establish directions. Okay, now just to keep things in mind here, on this unit, we are only going to be working with one-dimensional motion. Now, we live in 3D space. 2D would be a flat plane. 1D is just a line. So we are really only working with number lines here because we have to get 1D before we can move on to 2D. And if you have a number line, how can you define the directions? Well, typically we do that with positive and negative. And to more formally say, let me go ahead and say that this is like 1 meter, 2 meter, 3 meter, and negative 1 meter, negative 2 meter, and negative 3 meters. So now I could say that the aquamarine cylinder is 1 meter away. Its position, let's go ahead and say this, position we usually write with an X, like X marks the spot. The position of the aquamarine cylinder would be a positive 1 meter away from the origin. And the orange cube would have a position of negative 2 meters, or 2 meters in the negative direction. So now that we've established where exactly something is, let's start talking about a few other factors that are pretty important to motion in general. First off, let's give a little example here. Let's say you are going to go to the movies with your friend, and you walk, leaving your house, so your house is at the origin. You walk in a straight line to your friend for 2 kilometers, and then you meet them there, so their position would be positive 2 kilometers. Then together, you go to the movies, and unfortunately, when you get there, what you were planning on seeing is sold out. So you're like, you know what, we don't want to see anything else. We're going to go home, and let's specifically go to the friend's house and just hang out. Okay? And the question we want to ask is, how far have you moved, and how far has your friend moved? So let's go and focus on you for a second. How far have you moved? Well, most of you would probably say, this is a pretty simple problem, right? That, we started here, we went 2 kilometers, then 3, so that would be 5, and then 3 more, so you would probably say, oh, we've gone 8 kilometers. Okay, but be careful, because I said how far. I didn't say how far did you travel. So this is really vague. And similarly, couldn't we have said that, well, let's use a different color, that you started here, and you ended, yes, you went to the motion pictures and back, but you ended here. So really, could you say that how far you went was really just 2 kilometers? How do we answer this question effectively? And the answer is that there's actually 2 different ways to answer it, depending on what we're specifically looking for. When we say how far has something moved, there's a couple of different ways we can discuss that. The first one is the one that you're probably really familiar with, is you say, oh, they've traveled a certain what we call distance, which is the total length of the path from the start to the finish. So we'll give the example again in a second, but that would be going to your friend's house, then to the movie theater and back. All right, so that would be the whole entire thing. So let's go ahead and say that, just as a brief note, by the way, we usually abbreviate distance with a lowercase d. And a good note is that the units, they could be kilometers, they could be centimeters, it could be meters or whatever. We're almost always going to want it in terms of meters. Whenever we use it in an equation, we want it in terms of meters. The other way we can do this is we can define our displacement. Now, displacement you probably remember in chemistry as being like how much the water level goes up and down. You talk about the displacement of water. And that's not necessarily that wrong, because we were talking about the change in the height of the water, or the change in its vertical position. It's a similar thing here. Displacement is a change in position. That is its formal definition. And it is the straight line distance from start to finish. So we don't care about the entire path anymore, just the beginning and the end. That's it. And it must include magnitude. Now, a quick note, what does magnitude mean? Magnitude just means size, quantity, number. It has to have a number and a direction. And typically speaking, our directions are going to be positive and negative. You could say right and left or something like that, but positive and negative are way more universal. Quick note, displacement, the units are the variable is delta x. We're going to look at why that is in a second. And the units are also in meters. Now we actually have an equation for displacement. Remember, it is the change in position. So as a brief note, some of you probably have seen this. This is a delta. That triangle symbol is a Greek letter delta, and this just means change. And we're going to see that a lot, so you want to be familiar with that. So this is saying the change in x, or the change in position, and that is going to be equal to your final position minus your initial position. So let's go ahead and note that this is the final position in meters, and this is your initial position in meters. Be very, very careful. It is easy to mix those up. So this is x minus what we say is x naught. That 0 we pronounce as naught. So delta x equals x minus x naught. Similarly, and just as a quick note, your textbook, I believe, does this, and a lot of textbooks do. They do x final minus x initial. It's not incorrect. All of these are somewhat arbitrary, and you will see that a lot. But the big issue is that the AP uses this form here, and so I want to be consistent with them, and also it is a little more universal. So let's go back to this example. Let's talk about the distance that you move and your displacement, and the distance and displacement of your friend. If you want to, go ahead and pause it, try it yourself, and then come back and see how you do. But let's go ahead and give it a go. So for the distance for you, that is the total, remember, this is the total length of the path. So we go 2 kilometers, so that's going to be 2 plus 3 plus 3, so 3 plus 3. So our total is going to be 1, 2, 3, 4, 5, 6, 7, 8. 8 kilometers. And let's go ahead and do your friend's distance as well. Your friend goes 3 and then 3, so their total distance would be 6 kilometers. Now remember though, displacement's a little trickier. We want to make sure we use final minus initial. So for you, okay, let's be real careful. Your initial position is at 0. Your final position is at 2. So therefore, if I want to know your displacement, I would say 2 kilometers, so final position minus the initial position. So it is just 2 kilometers, which, note, is the straight line distance from you to your friend. Now, quick note, magnitude would be 2. The direction would simply be positive. Do you need to write the positive? No, we know that it means positive if you don't have this. But if you just want to be careful, you can feel free to include it. Let's talk about your friend, though. Your friend starts at 2 kilometers, so that's their initial position, but their final position is also 2. So they would have 2 kilometers minus 2 kilometers equals 0. Because the change in your friend's position is 0. They have come back to the same spot. Now, after defining how far something has gone, we often also want to know how fast is it going. And once again, we have 2 different terms to determine how fast an object moves that are different things. The first one, and let's go ahead and actually just briefly mention this. Let's say that you are on the highway, and let's say that you are going 100 miles. You're going to a distance of 100 miles on some trip, and it takes you 2 hours. And if I asked you, how fast were you going, you can already do that. Like, you're already built with that, by this point in your life. So you've gone 100 miles in 2 hours. I don't know if I said kilometers, miles, or let's say miles. You went 100 miles in 2 hours, so therefore it took you 100 divided by 2. The speed was 50 miles per hour. All right, and that's the same sort of idea here, except we're not going to use miles per hour as much. But speed, which we abbreviate with an S, is simply the distance you travel divided by the change in time. Pretty straightforward. We're used to this. And the units we're going to pretty much always try to stick with. Yes, you've seen kilometers per hour, miles per hour, but we really want to stick with meters per second. We need to have it in terms of meters per second when we use different equations. The other one's going to be a little more new to you, which is velocity. And velocity is a change in position divided by a change in time. So specifically, its definition is how quickly position changes or is changing. Now, we're going to look at the actual equation in just a second. But once again, you have to include direction. Just like displacement, which means you need to have a positive or a negative. Positive meaning you're going in a positive direction, negative meaning you're going in a negative direction. And the units are, once again, there we go, meters per second. Well, just like displacement, velocity has a very specific equation that we need to know, which is velocity v, I don't know if I said that earlier, but v is a symbol we use, is equal to the change in position over the change in time. So quick note, so this is velocity in meters per second. Delta x, remember we already learned delta x. This is the displacement, or the change in position, in meters. And then this is going to be our change in time in seconds. And if we want to write out our deltas, we can even say this is x minus x naught divided by t minus t naught. Oftentimes t naught will be 0 because we start our time and we'll say, oh, that was my 0 seconds was when I started. So a lot of times it'll just be t divided by t minus t naught, but it's the same thing. So now let's go back to the previous example. We've already written our distances and our displacements, and go ahead and define specifically how fast you and your friend have gone. Now, we didn't put times here, so let's go ahead and establish that now. Let's go ahead and say, for you to get to your friend, it took 1 hour, and then it took you all 1.5 hours to get to the motion pictures, and 1.5 hours to get back to your friend's house once you immediately turned around. Okay, so just to make sure we totally understand, that means you specifically had a change in time of, let's see, so over this whole time interval, you had a change time of 1 hour plus 1.5, 2.5, plus another 1.5, 3, 4 hours. Your friend's change in time was only 3 hours. Okay, so if this is the case, you are moving a distance of 8, so your speed would just be 8 divided by 4. 8 divided by 4 is going to be 2 kilometers per hour. Pretty simple. And your friend moved 6 kilometers in 3 hours, so 6 divided by 3 would also be 2 kilometers per hour. And that makes sense because you're able to walk side by side in this, later part of the journey. Now let's go ahead and also, though, talk about velocity, though. So your velocity, once again, it's 4 hours, but your displacement was only 2 kilometers. So I would do 2 divided by, and I'll even write this out, 2 divided by 4, and this gives me 0.5 kilometers per hour. And if I want to, I can put a positive, because it has to have a direction, but we just know it's positive if we don't put a negative on it. By the way, that is a 5. I know it kind of looks like a 6. Might be worse. And your friend went 0 in 3 hours, so their velocity is simply 0. That's all there is to it. Their average velocity, and we'll learn more about that later, is simply 0. All right, some final takeaways for this video, which you can really just consider to be the introduction to motion. At this point, can you define the position of an object using an origin and a direction? Can you distinguish between the distance an object travels and its displacement? And can you also determine how quickly it's moving, specifically with either speed or velocity? I would add one more on here. Specifically, can you also complete unit conversions? But we'll also practice that a little bit more in class.